Hello, everyone. Good morning, and thank you for joining us today. We are excited to welcome you to our session, Diagnostic CT Performance from Data to Confidence. This webinar is being recorded, and we will send out the recording to everyone. If you have any questions, please submit them in the Q&A tab at the top of the screen or in the chat box. It's my pleasure to introduce our guest presenter, Artur Koloshinsky, the sales director at Diagnostic. Diagnostic is an innovative phantom manufacturer based in Poland, known for delivering high quality, precise, and user-focused solutions for medical imaging quality assurance. They built a strong reputation for developing advanced phantoms that support accurate system performance evaluation across a range of imaging modalities. As the official distributor, Standard Imaging is proud to bring Diagnostic's products to a broader audience, combining their cutting-edge design with our commitment to customer support, service, and clinical excellence. Today, Artur is going to walk us through how performance monitoring and advanced software tools help identify deviations early, optimize protocols, support quality assurance, and maintain consistent image quality and dose levels across CT operations. We're thrilled to have him with us, so take it away, Artur.
Thank you, Ashley, for this introduction, and thank you for sharing and allowing me to share our solution for the wider audience. And so let's start. I will, based on my presentation, from data to diagnostic confidence. I will start, and in the beginning I will make a loop and then go to the end of my presentation and say, okay, data and confidence, it's a loop, but how to have a confidence? When we have a data, we base on our senses to analyze them, but if we could exclude our senses and allow the machine to analyze the data, the confidence would be much higher. The agenda of this meeting is briefly we'll go through what is an imaging, how we do the tests, and then why we'll focus on our solution in computed tomography and radiotherapy, regarding with the big stress on the software, which allows to automatize the whole process and make it more confident. So what is imaging QA? So all types of equipment, we call them modalities, subject to quality control. X-ray, nuclear medicine, also diagnostic part of radiotherapeutical medical devices need to be checked. And users want to maintain high clinical standards, and also they are obliged to perform quality control by legal regulations. The general purpose of the QA test is to ensure patient safety by verifying the most important parameters of the diagnostic equipment, such as image quality and those that is received by the patients. So quality control is performed using dedicated phantoms, and this allows to evaluate the equipment in standardized and reproducible way. We can measure the same parameters in different ways, with different tolerances, and the norms like DIN or IAC norms describe what kind of parameters we should measure and what are the tolerances. Moreover, we have bodies that also make guidelines, like ACR, or in Europe, the European Federation of Organizations for Medical Physicists, or EUREF. So these guidelines are also very important tip for the medical physicists, how they can measure what kind of formulas or tolerances they can use. Moreover, if we don't find anything in the norms or guidelines, we still have scientific publications in different magazines or regarding the posters or abstracts in the conferences. So they also describe how we can perform the tests and then what we can do. How we do the tests. We do almost the same measurements in different modalities. So from top right, we have a CBCT in X-ray, in fluoroscopy. We have an X-ray or fluoroscopy phantom for the CT. We measure the we measure also the spatial resolution or MRI, or at the top right, we have a Yashchak phantom. So uniformity, it's always about the noise artifacts. So it's a plain part of the phantom where we are looking for measuring the uniformity or uniformity and then looking for some artifacts. The contrast resolution, we usually have some pair of lines in the radiographic phantom, sandwiches of pair of lines in the CT phantom. In MRI, we have dots that we try to distinguish the roles that it will regulate how what is the desired, what is the read resolution. In the dental, in the low contrast, we base on the contrasts. So dependingly, yes, we have here few examples for dentistry, for X-ray, for CT, MRI, or nuclear medicine. Geometry, it's very important because if the image will be out of focus, it will be hard for the radiologist to verify and then find the crucial things. So this is the essence of the QA also to verify if the image is not out of focus, it's not blurred, because otherwise it will not have the medical value. So let's start from the computed tomography. We have a pro-CT dose phantom. So the purpose of this phantom is to stimulate the patient's body, and calculations are made to estimate the total dose of the patient. So not only the image, but also those measurements take into the account, and then we have to look for the things that make the whole QA procedures fine. So how we do it. So CTDI is defined as with the formula, which you can find at the bottom. We measure on the outer ring for values of dosimetry phantom therapy, and then we calculate the CTDI. ProCT-MK2. ProCT-MK2 is imaging phantom for the CT, and it's a quality assurance phantom designed for routine quality control, constancy testing, and acceptance testing in diagnostic CT systems. So we can make the following tests like geometry, deviation of the HU value, noise or level and uniformity, artifacts, MTF, SSP, LSF, PSF, CNR, high contrast, the Z-dimensional spatial resolution, low contrast, slice profile, slice thickness, isocenter, compliance, and linearity. The ProCT-MK2 got the modular design, and we can take it apart. We can use only the models that we want to test if we don't want to make the whole procedure, the whole test procedure and all the tests. So allows us to make a structured and repeatable QA measurements aligned with the routine clinical workflow. We have a low contrast model. So to evaluate the number of distinguishable low contrast objects in each group, But please note that reference values should be evaluated by performing a series of about 5. So each day we should make the check and mm, uh, they should be counted as a base check. So then when we make the routine testing, when we make the constancy check, we refer to the base tests, and then we can see if there are any deviations. And after the installation. So this kind of test, this kind of baseline should be also redo after the modifications or repairs of the devices. The diameters of the rods are from 1 to 13, from 1 to 7, 5, 7, 9, 11, 13, and 15. So the last visible group is 0.3% comparing to the background, and 0.6 is the middle one, and the most visible is 1% comparing to the background. And regarding the software, we have an automated analysis software. This is how it looks. When we make the analysis, all the groups are checked, verified, and then analyzed and submitted in the report. Next model, it's a sensitometry model where we are looking for the HU values for each of the samples. We have the 9 samples, and it's air, so air and water. This is the things that are always the same, and we can base on this when we make the other checks, when we make the other verifications, when we measure other samples. Differ less than 4 HU from reference values should be acceptable. And it's also when we upload the DICOM, we can see that all the tests and also the sensitometric model can be analyzed. We have all the values written with the tolerances to the reference value, what is the difference, and we have the graph also showing how it's compared to the base check. When we are making the constancy checking on the timeline, we can see if it's always the same values or something have changed. So when something is changing, we should be aware that something's wrong with the machine, and we should take a closer look to the machine. Regarding the tolerances, we can always set us the software allows us also to set our own tolerances regarding our protocol, so we can set it up, customize the efficiency of the software to work as our workflow, as our procedure. We have a geometry model which serves us to make some more calculations. With the geometry, we can measure the distances between the rods in the horizontal, vertical, and diagonal direction. So the rods are placed in the vertexes of square 10 to 10 rotated by 45 degrees, and diameter of each rod is 5 millimeter. Contains 4 rods with a diameter of 5 and 4 of diameter of 3 millimeters from the air in the vertex of a rectangular octagon close to the outer perimeter of the phantom for evaluating symmetry and circular geometry. So dimensions measured on the image shouldn't differ from the actual values more than 1 millimeter. And here also we have the values from the software after the automatic analysis with all the values listed in the tab for the geometry test. With the geometry model, we can measure also the length of the ramps using the FWHM procedures to divide by 2 to get the slice thickness. So measured slice thickness should not differ more than 20% from the actually set value. And here also we can look at the tabs for the software where we have the alignment for the Excel positioning and also the slice thickness measurements. When we go to the resolution model, we have the from 1 to 31 pair of line of per centimeter per sandwiches in the outer ring. And we have to count the number of distinguishable high contrast objects, and it should not differ from the reference values. So when we make the base check, then on the constancy checks, we have to verify if we can distinguish the same number of pair of lines. Also, we can measure with this model the MTF. Here also you can find the screenshots from our software where we can see the bar phantom bar patterns profile analyze and also the MTF degree of the Morian. Here we have the special resolution with the MTF wire, values for the measurements of the wire, and also the MTF measurements for the bed. So we can measure the MTF in few different ways. All the measurements are in the analyze. Then we have the homogeneous model, which is water filled, water with real water. So with the homogeneous model, we can measure the value, HU value, mean value of water should be 0 plus minus 5 atmosphere degrees. We can also measure the noise. So measure a standard deviation of transferred units in 40% of the phantom ROI in the center of model, and standard deviation in ROI shouldn't differ more than 20% from the reference values. Here we have the mean CT number analyzed and also the noise level. So everything in the tabs like you see. With the homogeneous model, we also we check for the artifacts. So the artifacts test is that we should not see significant artifacts on the or absorptions in the visible area. On the left, we have a different examples of artifacts or distortions. So when we make the measurement, when we make the acquisition, there should be the image should be like on the image on the right, without distortions, without artifacts. And the software allows us to analyze. And please take these measurements are usually described as should be human confirmed by the human verification. So if the software has a supportive role, so it always gives us the information tab information window that the analyses have been made, but it should be verified with the naked eye by the medical physicists if it's okay. And when I was talking about the real water, I think that medical physicists prefer the real water because it's always regarding the energies, it's always have the same value. Regarding the solid water, the HU value depends on the kilovolts, where at low energies we have different HU, and when we increase the energy, it also changes. So CT scanners are calibrated for the attenuation of real water that corresponds to zero, and epoxy. So the resin-made materials contain additional elements beyond the hydrogen and oxygen, so their attenuation differs from the true water. As a result, their AGU values can shift across different kilovolt settings. With the homogeneous model, we measure also the uniformity. So mean value of Hounsfield units in 10% of the phantom voice selected in the center and in four places near these borders. The difference in HU between the center and sites should be consistent in time and differ less than 4 Hounsfield units from the reference values. Here, here we can also see how we can support with the software and what gives us the output of the measurements instantly. Regarding the packaging, the Phantom is inside hard-sided box together with the adapter and dedicated hair case, which serves as a counterweight also. But we have another option of dedicated adapters for various manufacturers, for GE, for Canon, Siemens, and also we are working on Philips. So this allows us to use the demo fingers from the OEM, from the manufacturers, and it's much more stable, much more robust. And when we compare Pro CTMK2 versus the flat funds, it's the advantages of our Phantom is that Pro City MK2 is much quicker and easier to set up and position. In CatFun, we have only solid water. And as I showed that HU variability, unlike the water, it's a big bottleneck. So, but on the other side, we have also option for the solid water homogeneous disks. So if someone don't want to deal with filling the model, you can use the solid water also. We have the big advantage of the diagnostic software that provides automatic analysis for the ACR, MRI, and CTMK2 and other diagnostic radiology phantoms, and the Phantoms Lab SMART does not support. So the combination of the Pro CTMK2 dedicated multi-link adapters and the pneumatic automated software delivers workflow ideal for the busy hospital environments. Regarding the radiotherapy, we have a Pro RTED, so this phantom is used to account the tissue heterogeneity in the radiotherapy treatment planning. It can be used to define the precise correlation of the CT data to electron density of various tissues. The phantom consists of two nested discs that represent the head and abdomen. 9 different tissue equivalents with the different electron densities plugs can be positioned in 17 different locations within the scan field. And included is also a water vial plug that can be filled with any fluid. It's pretty potent phantom, and you use it on the daily basis. Because it's needed for the treatment planning values to measure the Hansfield unit, the CT value, and evaluate the CT scan data, which is needed for the corrections for the inhomogeneities in the treatment planning. Document relationship between CT number and tissue electron density to simulate indicate tissue with the diagnostic energy range and quick assessment of distortion of the distance registration. I already have showed you that our software allows to have the objective data. This is very important because the objectivity it's the main thing that differs from the analysis that we make with our senses. We can have a worse day, we can be tired, we can be not see properly or be busy and distorted, but the software and the constants data, it will always show the objective output. So this is very reliable tool. Moreover, it's very fast. So together with the adapters for the CT Phantom allows us to skip like 10 to 15 minutes for the first part of the procedure of the phantom positioning. We don't have to position. Once we will position it and align with the lasers, we put it on the shelf, and on the constant checks next time, we just put the adapter, hang the phantom, and we can make the scout and then scanning. So saves a lot of part of the procedure. But regarding the analyze for the CT, it shortens the analyze time. For the skilled medical physicists, it's about 30-40 minutes. For the not skilled medical physicists, it can be even 1 hour or more. With the software, it shortens us for the few minutes, 3-4 minutes, and we have the report on our email or on our iPad or mobile phone, where we can check if all the values are okay, if everything is all right, or we have to check maybe the phantom was positioned wrong, or maybe the machine is giving the output which is not exactly good. So the procedure, the solution works like in this graph. So we scan the phantom. This is the thing that we have to do. It's always the same in the beginning. And then we can button up the device with the Diacom node, which is called Diagnostic connector. So instead of saving the sequence the acquisition for the packs, we push it for the cloud and receive the report on our email or mobile phone in a few minutes time. So it saves us another time and automatize the whole process. So we don't have to physically or log into the computer, just on make the acquisition, put the diacom node, so in the this program, the IP address of the machine, set the port, and everything is button up. So once we make the acquisition, it goes directly to the cloud to be automatically analyzed, and we receive the report in a few minutes. And regarding the applications, we have support for all of our phantoms. So not only for the CT, but also for X-ray, for uh, MRI, for mammography or nuclear medicine. So if you are using, if you are making the QA and your facility has a lot of diagnostic equipment which needs to be checked, it allows us to save a lot of money, a lot of time and money to if we facilitate this workflow. It allows us, especially when we talk about the more complicated analyses like CBCT analyze, MRI or CT, it can save us much time. But also mammography, where we have to do the daily checks. So in total, multiplying the amount of the machines, it gives us real value that for the save time we can spend this time on the procedures, so we can free up these time slots for the patients. When we have few RF units, few mammographic machines, 2 or 3 CTs and MRI, it's usually we can save like 25 working days per year. Thank you. This is, well, it was a pleasure to give you the please contact with the standard imaging sales force.
Thank you so much for that wonderful presentation. Have some information on the screen there if people want to take that down. Now would be a good time if you have any questions for Arthur to just submit them in the chat. I've been answering a few throughout the presentation, or you can submit them in the Q&A tab. I'll take a look here. We do have one for you. They're wondering the limitations of using the Pro CT MK2 on cone beam CT, if any. Thank you.
Probably, if you would like to use yes, there are limitations like the cut fan. So to have a body shape, you would need to use the hardening external rings, the oval shaped rings, which are also available. So if you would be interested in the solution to have the oval shape of the phantom, which allows you to put the phantom inside, yes, we have such a solution.
Awesome, thank you for that. One is asking about if we have any representation for sales in Latin America. I'm not sure if Umar or Arthur want to address that.
Yes, I mean we do have representation in Latin America, like Ashley was saying. Please, feel free to reach out to our sales email here. We'll handle any sales questions in the US, Europe, anywhere else in the world as well.
Awesome, thank you. I'm not seeing any more, just a lot of thank yous. So thank you again, Arthur, for this wonderful presentation. Thank you for everyone for joining us today. Like I said at the beginning, we will have this recording on our website, and we'll email this out to you guys. So you'll have that available to review or to share with other team members. So we'll end it here, but thank you so much, everyone. Have a great day.
Thank you.